Holy cow! We actually started off without somebody being in mid-sentence. That's got to be some kind of record for us, guys.
Doing it live.
Doing it. We are now live. So thank you for everybody who has joined us live. Thank you if you join us after the fact. This is our October live stream for 2025, and I am truly excited because we've got somebody that actually I think has made a tremendous contribution to the hobby of ham radio over the years as our special guest. And I'm referring to Dale Parfit, W4OP. We're going to get into some of Dale's exploits, and I consider them to be very impressive shortly. But first, why don't we just go around the table here and see what people have been up to? Chris, looks like you've got done a little bit of housekeeping in your studio there.
Yeah, yes, I have. I moved the shack around for a couple of reasons, and one was to kind of make this space a little more multi-purpose for different YouTube activities. So that was one of the reasons. And the other one was when I finished my doctorate, I actually had this desk that I put together that was a good sized desk, which is really, it was a simple project. It was a Home Depot like kitchen butcher block style countertop and then 2 IKEA file cabinets, and it worked for that. So I brought it down here, and then it actually, most of my ham gear fits on the desk, so which is great. So I reconfigured everything. You know, it's always good to take your shack apart and rewire it every once in a while. So I did that, and yeah, I think there's a video forthcoming on that. I'll do a quick shack tour and what I've done with it. So that's changed around, and haven't had much time on the air. But what I'm looking forward to, though, it's October, so CQ Worldwide's coming up, and I do like to get on for that and maybe find a country I haven't worked yet. So that's the latest on my end.
Good stuff. Good stuff. All right. Hey, Tim, N9SAB, we just got, Philip's wondering how come you're doing the stream from your bathroom?
That's good. Yeah, I like that. It's a very expensive rental bathroom, too. It's actually like a giant porta potty.
Is it an editorial comment?
No, I'm on the road, so we're busy. Shopping for bunkers, visiting some customers out here in West Texas.
And what's happening? What was that?
That was my phone.
Oh, okay. Tim, any radio stuff? How's the antenna thing going?
I was gonna bring my little True SDX with me and try and play around with it out here, but I've got so much stuff and I'm trying to do so many things. It wouldn't work.
You know what's cool about where you're at is that the desert has this strange thing going on in it. I think we touched on it a little bit with Ray from ICOM a few months ago, but if you're putting up a wire antenna, you don't have to put it up as high above ground as you do where we live, in the Northeast or in the eastern part of
Depends on the geology. There's a lot more quartz and stuff like that around here. Yeah.
Yeah. So
it would have been interesting to test, but it's just, traveling is the worst. You don't sleep right. You don't eat right, so it wasn't going to happen.
Absolutely. Okay. Just quickly then, I'll just give you a bit of a recap. I am fresh back from Northern Ontario, and I mean Northern Ontario, the northeast corner of Lake Superior, Puckasaw National Park, which is a 13-hour drive from my home. That is a long drive, let me tell you. But the spectacular, the scenery is absolutely jaw-dropping. And had a Parks on the Air activation up there. And I've got a video out next week where I'm going to share what happened, but there's also a Bigfoot element to it. So stay tuned for that one. Now, something else and by the way, Dale, I am the cryptozoologist around the table here. So I'm into, and by the way, you're from Western North Carolina, and you mentioned Asheville earlier. One of the leading cryptozoologists is in the United States is actually in in the Asheville area. His name is Micah Hanks. But he's got a number of regular podcasts. Now, aside from that, guys, I do watch the used listings, and I'm afraid that I'm going to cause my friend Tim to sign off for a couple of minutes here while he cools down. But I came across this device, and it's I just wonder if anybody is going to be able to recognize it. Yeah, I haven't even unpacked it yet. It came in. You guys familiar with this at all?
It's a doorstop.
Well, no, actually.
Who is the manufacturer?
It's a paperweight.
The manufacturer is Chameleon.
It's an element for a water heater.
Tracy, again, you're crossing that line with Tim here.
Well, but Tim's to blame. I'm going to say very seriously, Tim is responsible for this. No, he's responsible because he had such good luck with his 17-meter hamstick dipole that when I saw this, I thought, you know what, I'm going to go for it. A guy up in Ontario here purchased this, never got to use it. This is a hamstick dipole mount, but it's got provision for the bands on it. So you put, you see the red terminals here. You screw hamsticks for one band in those, and then hamsticks for the other band here. So you've actually got two bands with it. It comes with all the mounting hardware. I mean, it's got everything complete in the box. There's a tower mount that screws onto the bottom here. So I'm going to have some fun with that at some point.
So if I put like a 20-meter elements on one side and then 10-meter elements on the other, it'll be like a little Yagi.
Well, it's not. It's like a fan dipole, if you will, but for two bands.
Oh, okay.
Right. Yeah. So you can't. You can't. Yeah, you won't run more than two bands, but it'll do. They made another version of that, which actually had provision for 4 sets.
Yeah,
I think they called that one the Spider.
Didn't MFJ?
So there you go.
I think it's wonderful. That's actually a clever piece of equipment. That's cool.
Well, but I thought MFJ made something like that. Didn't they? Stop! Mighty Fine Junk.
Have you talked to me before?
Mighty Fine Junk. We all have it.
No, we don't. I divested myself of that stuff a long time ago.
Yeah, we do. Yeah,
everyone's got something from MFJ.
No, I've never owned their products.
I think I mentioned. I think I mentioned my MFJ horror story. I don't know if it was last year on the stream, but yeah, I once burned, never again. So, Chris, you mentioned it. CQ Worldwide Single Sideband Contest. Yep. I have my campsite booked for the weekend after this upcoming weekend.
Yeah, I know you're hardcore, man. You do it outside. I wouldn't even think about that.
Outside is where the action is. It's fun outside. It's adventurous.
Tracy, it's freezing outside.
It's a little cold. It's gonna be a little cold up there, isn't
it? You know what? But what the Norwegians have a saying: "There's no such thing as bad weather, only bad clothing." So you take the right clothing.
You know what? I'm not Norwegian.
Where's the campsite?
What's that?
Where's the campsite?
So the campsite is actually going to be in a community not far from me. It's only going to be about a half an hour drive. So that's.
So if you get cold, you can come home.
No, not. Last year I almost caught hypothermia. During that contest. I was a little bit further afield and up north, and that was a chilly night. Let me tell you.
Tracy, listen, I'll be sitting here in the warmth of my home. I'll be tuning around on my radio, quite comfy in my chair. Everything will be great.
And next year, you won't remember it at all. And I'm talking to everybody who's watching this. Get out, try it from the field. You think POTA is fun? CQ Worldwide Single Sideband is even more fun. The bands are jammed. You put up a decent antenna. You are going to be working stations across the globe, as I did last year. and you're going to have a heck of a time, and you will remember that for years to come. So my wholehearted encouragement.
Right.
Guys,
I'll remember to convince myself to never do it again.
Okay, it's time to roll it around. Dale, before we get into your stuff, your backstory and all, hey, what have you been up to over the past few weeks, ham radio wise?
Well, my tower is about it's on a ridge up above the house, and I have ignored this. It's in the middle of a forest, and I have created a space up there. But over the years, it's gotten grown up, and I've got a box up there for my 6-way remote antenna switch. And despite the fact I've got holes sealed up in things, a mouse got in there who knows how long ago. And what I started noticing was my Elecraft KPA 1500 was faulting, and I couldn't figure it out. Well, I finally went up there and took the lid off, all 8 screws, and there was a mouse living in there. And he decided that his bathroom would be the PC board for my 8-way switch. Everything was just a mess up there. Everything's overgrown. So I've spent hours up on that hillside cutting down saplings, repairing antennas. And I'm almost done with that project. But then I don't do a lot on HF, but I like 10 meter AM on 29 megahertz even, and every 10 KC up from there. And now with the winter coming and F2 layers coming back, the band is open daily. And the Elecraft does a nice job, the K4 on 10 meter AM. But I've always admired the Clegg line of radios, the 22er, 99ers. Yeah. So I had a beautiful mint 22er here, and I converted it to 10 meters. And if you look at the front panel, it no longer says 22er, it says 1010er. And the scale is perfect. It's no longer 2 meters. It's now 29 megahertz plus or minus about 100 kilohertz. And I use that every day. It's plate modulated, and I drive the KPA 1500 with it to about 200 watts carrier, and I'm having a ball on 10 meter AM working all over the world.
Wow. The Clegg radios back in the day were like the Cadillac.
Absolutely. Yeah. I mean, Teflon wiring, stainless hardware. Yeah, they're really well made.
Yeah, that's right. Yeah, Tracy, they'd give your SGC radio a run for its money. The old Cleggs.
Absolutely.
You were talking about selling the SGC, Tracy. Any luck?
You know what? I'm floating it out there. No takers yet, but I've got a big contest coming up, and so I'm going to hang on to it for a bit.
So before we go on, too, look.
Buc-ee's.
Yes. Yes. I went to the Buc-ee's in Bastrop, Texas, somewhere. It's phenomenal.
And dumb Canadian here, I have no idea what Buc-ee's is.
I have eaten more beef jerky over the past 2 days than imagine a giant truck stop where there are no trucks and everything's clean, right?
Yeah. Yeah, pretty much.
Just every kind of beef jerky and candy and food and clothing item, camping stuff. It's wonderful.
Yep. Tracy, you'd love it.
Yeah, you get a kick out of it.
I think I would.
Yeah.
Sounds pretty good. And they've got a beaver as a mascot?
Yeah.
That's probably a Canadian company.
I was going to wear that, but it's a little warm.
Yeah, during the desert. All right. Good stuff. I want to introduce our guest properly here. Dale W4OP. And let me just bring a screen up here. I want to see if I can figure out this. I'm going to go back to the very first video is that going to work? Try this again. The very first video. Yes, he said that. Stop screen. Okay. Share screen. Come on, work for me. All right. The very first video I ever created was one called Using Fiberglass Poles for HF Portable Operation. Do you see what I'm holding in my hand there? That is one of Dale's antennas. And by the way, that video there was supposed to be a one and done. I was going to just, here's a video because I've got so much value out of watching ham radio stuff on YouTube. I want to I want to offer something to the community as a way of thanks, and then I'm out of here. And this video is a hack job. It's a complete hack job. It's my first. I'm not talking loud enough. It's dull. But there's one of Dale's antennas, because Dale actually had a product that answered a problem for me. Now, if we go back to the early 2000s, the conventional wisdom, and guys, you're listening to somebody here. I didn't have any Elmers per se. My Elmers were CQ magazine, 73 magazine, QST. I would read them voraciously. I would read anything online. And back when Dale started selling these end-fed antennas, there was nobody else out there really selling these. And the conventional wisdom from all the know-it-alls was that end-feds don't work. They are a dummy load. And that was the prevailing wisdom.
Yes.
Now, I am I'm very pleased to have Dale here, because he is, in my mind, the man that is responsible for bringing the end-fed antenna, which so many of us use. And that's, for so many of us, it's our go-to choice for a portable antenna. Dale, I don't think if you hadn't pushed that barrier that we would be using these today. And so what I'd like to do is maybe ask you, okay, take us back. And I hope you tell us a little bit more of the backstory, because you started off with, and when I say started off, that's not really how it happened, because you had history before that, but you were with Avanti Antennas. And I'm hoping that you can maybe walk us through your interest in radio, how you got started, and then into the work that you did leading up to Avanti, and then how that all sort of came together to end up with the PAR end feds line.
Sure. So I think, like a lot of us old timers, I started listening to we had a Zenith Cathedral radio, and I was listening to shortwave and got interested in that. And we had a neighbor a block over who was very active, and he said, "You should get your license." And that was in Elmira, New York, and we had a night school. And W2ZBJ and W2HQY taught a ham radio course for novices. And you had to be 18 years old. You had to be an adult. And I was 12. So my mom said, I'll attend and I'll be babysitting you. And so I got my novice license and general license. And back then that was about all you needed. And but my interest in ham radio just grew and grew, and I was building small projects and things. And then when it came time for college, I really wanted to go to Syracuse, which wasn't maybe 2.5 hours from Elmira. Very expensive private school. And serendipitously, their cross-country and track coach contacted me and offered me a full scholarship, running scholarship, to go to Syracuse.
Nice.
Nothing wrong with that.
You're an Orangeman.
No, it was expensive back then, and now it's out of sight, I suppose. But anyway, so I got my BSEE there, and then stayed on for my master's degree and helped coach the track and cross country. And my first job out of grad school was a brief stint with Sperry Flight Systems out in Phoenix, and I just really didn't fit in there. And I was married to a girl from Florida, so we moved to Florida, and I started looking for where I might go to work. And I looked up laboratories in the yellow pages, and the first listing was Avanti, Research and Development. They had a winter laboratory in West Palm Beach. Their main home was Chicago. So they hired me, and we really had some very novel antennas, so many patents. But one thing I started looking at was a marine antenna. And I thought, well, how does this thing work? It doesn't have any radials on it. And it was a half-wave antenna, VHF antenna, with some sort of matching network. And I thought, well, that's pretty clever. And years passed, and I thought, well, why couldn't we do something like that on a vehicle? Because the impedance of an end-fed antenna is very high impedance. So it doesn't take much to couple that. So we had the half-wave radiator on the outside of the vehicle for 2 meters, 220 and 432. And then on the inside was a matching network, which was at that time a parallel LC network, which you ground one end, the other end is a high impedance. And so we had a plate inside that box, and it would just couple through the glass, even though the coupling capacitance was only maybe 10, 15 picofarad. When you're dealing with 4,000 or 5,000 ohms impedance, that's a short circuit. So that was my first antenna patent. And then years later, I've always been into hiking. And Elecraft came out with their K2, and I built one of the first ones of those. And a dipole was kind of inconvenient for hiking. And so I thought back to the on-glass antenna, and the first one I did was 20 meters, a 33-foot radiator. And instead of the distributed matching network, which you see in the original ZEP antennas, that sort of thing, I did a lumped element, and it was an L network to convert the 2,000 or 3,000 ohms of the end-fed wire down to 50 ohms. And that was in a small plastic box like the one you showed, Tracy. And I started making those, and I asked a very trusted friend whose name I will not mention, what do you think of this as an antenna project? I was already pretty busy with filters, and my line of omnidirectional VHF, UHF antennas. He said, Dale, I just don't get it. I don't see what the advantage is here. And I ignored his his thoughts and went ahead and developed these. They were originally all monoband antennas and using the L network. So I'm going back 30 years now, I think, because we didn't have inexpensive VNAs back then. I did have a Hewlett-Packard VNA, but I wanted to find out, what is the end impedance of a half-wave wire in space. And I think I solved the equation for a single wire transmission line above ground. And what affects that end impedance is the height above ground, as you might suspect, and the diameter of the wire. And so I solved all those and started making these matchboxes. And I used a powdered iron core for the inductor, and for the capacitor, I was using lengths of RG316, which is a Teflon silver mini coax, about like RG174, an 1/8 inch in diameter or less. And all 50 ohm cables are 27 picofarad per foot. And so I would figure out how much capacity I needed in that matching network and cut off a piece of that and to the appropriate capacity. And that's how the matching networks were done. And I went to Dayton the very first year with the NFEDS antennas. I'd already been setting up for years with the omni-angle antennas and my filter line. And I got a lot of complaints because I was calling it an NFED half-wave dipole. And a lot of hams were very kind to inform me that if it's NFED, it cannot be a dipole.
Right. What a surprise. Hams go out to correct somebody. Gee.
Yeah. So I said, well, fellas, I'm not going to depend upon amateur nomenclature, but I will take the definition of the IEEE, which is the Electronics
right.
Engineers Professional Society. And they define the dipole. They don't care where it's fed. But the die does not mean 2 wires. It means that there are 2 voltage loops on the antenna, 2 voltage maxima. And they seem to accept that. So anyway, they were selling like crazy. And then I designed a multi-band one using a ferrite core and 3 turns by filer, and then I think a total of 27 turns. And that was a broadband matching transformer from high impedance back to 50 ohms. And that was pretty successful too. But what I found was that the SWR was getting worse on 15 and 10 meters. And that turned out to be too much winding inductance. So I added a shunt capacitor. And this is what you see today all over the internet to cancel out some of that inductance. And so I did 10, 20, 15, 10, and then, it's too many years now, but that was the beginning of the broadband transformer. And it's been copied and copied and copied. I'm not sure people understand what the capacitor is there for. And I mention that because I know a lot of people are building an end fed for 160 or 80 meters. And they use the ferrite core, and it's a big honking ferrite core if you want to run high power, and the big shunt capacitor, about 100 picofarad, I think. Whereas a better solution for a mono band antenna is still going back to the L network from the first designs I did. It's a lot cheaper. You can use a powdered iron core for the inductor or an air wound coil. And for the capacitor, you can just use lengths of coax. It doesn't need a high voltage, high current capacitor that the ferrite transformer needs. And it's more efficient. Now, not a lot, but maybe a half to 3/4 of a dB, but it's less expensive too, and smaller. So, but the monoband has just gotten out of vogue, I guess, and everybody wants a multi-bander, and that's where the wideband transformer comes in. But for those of you that want to do a monobander, the L network is still the way to go as far as inexpensive. And you can tune it too. You can trim that coax, maybe a 1/4 inch or 1/8 inch at a time, and you can tune the antenna. So that's kind of been lost in time, I guess.
Well, this is like some serious engineering here. This wasn't like somebody. I'm going to throw a wire up in a tree.
Yeah, that's right.
Yeah,
and
this is great.
I guess everybody wants to know, does the end-fed antenna need radials? And the way I look at this, and I think I'm correct, is if we look at the 2 limits, one would be the quarter wave ground plane, which needs a lot of radials to be efficient. Doesn't need a lot of radials to have a low SWR, but that feed impedance is so low at around theoretically 37 ohms that the more radials, the better. And in broadcast situations, you'll see 100 radials on these quarter wave towers. So the antithesis of that then is the half wave antenna, which is an extremely high impedance and doesn't require much in the way of radials. When I was first developing these antennas, I saw a very slight hand effect as I would be holding an antenna analyzer and matching the antenna, tuning it for low SWR, and then I would connect a random wire to the shield of the coaxial cable. And in fact, it wasn't even the coaxial cable. I had the matching network connected directly to the antenna analyzer. And as I added a wire to it, hardly anything changed at all. So if your coax lays on the ground from an end fed, that capacity to ground is more than sufficient to supply the return path to the antenna. You can't push power into an antenna with just one terminal. It needs 2 terminals. So the other terminal is either the shield of your coax or it's a short ground. Doesn't take much at all to provide that return path. And it's just so convenient to throw one end up into a tree, connect the other end on my K2. I would just use a double male BNC connector and connect the matchbox right to the radio. And never any feedback, never any problem at all.
Wow. Well, Tim, you're weighing in on this.
Here's one other fact that with, as Tracy mentioned, with a fan dipole, you can continue to put wires on that, but a fan dipole doesn't work with end-fed antennas. It's gonna look at the overall average length, and there will be one resonance on there. But you can take the half-wave antenna, and whereas with a current-fed antenna, it is resonant on odd harmonics. For instance, a quarter wave antenna will also work as a 3/4 wave antenna. Say a 40-meter quarter wave will work as a 3/4 wave on 15 meters. But with the end-fed antenna, it is resonant on every multiple, not just even and odd. So a 40-meter end-fed will work on 20, 15, 10. There is a little effect that if you resonate it on the end-fed at 7 megahertz as a half-wave, 66-foot wire, then on 20 meters, it's going to be resonant at about 14.2 or 14.3. On 21, maybe 21.5, and by the time you get to 10 meters, it's out of the band. And so the way I solved that problem was, let's look at the simplest case. A 40-meter half-wave antenna is a full-wave antenna on 20 meters, but it's resonant, and with a wideband transformer, you can get a low SWR, but it's too high in the band. So what I did was I added a short stub at the middle of the 66-foot wire. Now that is current maximum on 40 meters. So it's invisible. It's just like the boom of a Yagi. At the current maximum, that boom is invisible. But on 20 meters, that is a very high impedance. And so it doesn't take much of a wire to lower the frequency and get it back into the portion of 20 meters that you want to use. On 15, you can put a stub at about 11 feet out, which is current maxima on, well, it's not current maxima anywhere, but it's current minima on 15 meters. So you can now trim that stub, and you can independently tune the bands now by having these stubs at current minima or voltage maximum on the different bands. Now, I think it's called My Antennas. They have really gone great with this. And what they did, very, very clever idea. They put a coil close to the feed point. If you've ever seen that antenna or its copycats. And that inductor is pretty much invisible on 40 meters. It's more visible on 20, so it loads the antenna. More so on 15, even more so on 10. Very, very clever design. I'm sorry I was never smart enough to think of that solution. But both work, either stubs at the for the different bands or that coil. The better part, I think, of the stubs is it does allow you to pretty much independently tune each band, whereas with the coil solution, you can change the length of the antenna some, but that's the only way you can try to tune it, and that affects all bands. So that coil idea was pretty darn clever, I have to admit.
Hey, Dale, we got a question here from Zach. Did you experiment with a small inductance near the feed point?
I think that's what he was just talking about, right?
Yeah, that's what I was just talking about. I wish I had been that smart. I did not. I used the stub solution, which has advantages, and it's a little more complex, but it does allow you to tune each band independently. I thought the inductor near the feed point was brilliant.
Very cool. Hey, if anybody watching this has a comment, throw it into the chat. A question for Dale, throw it into the chat, and we'll get Dale to respond on it. Okay, Dale, there's a unique product in the end-feds line. I just want to take one moment to address here, and that is the SWL product, which is a 45-foot length and has a ground connection on it. I'm curious. I actually have one of those, and I actually used it for the thumbnail for this stream here.
Yes.
and it works very well. I'm curious, that 45-foot length. Why did you settle on that length?
What I was trying to do was to avoid resonances in the popular shortwave, not in the ham bands, but in the popular shortwave bands like 13 meters, that sort of thing, 41 meters. And so that length avoids those resonances, and the 9-to-1 transformer just works extremely well. It's pretty much broadband there. It's not perfect on any band, but it's very good on all bands. And gosh, that was an afterthought, and hundreds and hundreds of those were sold, and with very, very good reviews.
Yeah, it's a tremendous antenna.
And it had you could ground it. There were 3 studs on the back, unlike the ham band with 1 stud just for the antenna. There were 2 studs. One was a ground for the primary of the transformer, and one was a ground for the secondary of the transformer. And it came with those 2 shorted together. But depending upon the type of noise that you're experiencing in your environment, if it is extremely close in near field noise or far field noise, and where your antenna was located, you could try grounding either the secondary or the primary or the factory select where they're grounded together. And I heard from a lot of people that many times grounding the secondary, which is the antenna side of that transformer, resulted in the best noise. And you'll see comments on W8JI's page on his beverages and using the beverage transformers that he makes a big point of grounding just the secondary side, and do not ground the shield of the coax at the antenna, ground it further away, and that reduces common mode on that coax.
Very cool.
So a lot of thought went into it, but it was really an afterthought, and it was one of the best-selling antennas.
Yeah, it works tremendously. Anybody who is looking for a short wave listening antenna that performs well across the HF spectrum, that may be the best one out there for you. Okay, there is a question here. Dale, maybe you could take a look at this one. Which unun is best for an end-fed half-wave antenna using 66 feet of 18-gauge wire, 49-to-1 or 64-to-1? Maybe there's just an underlying thought that you want to apply to this.
The first thing I would say is that the term unun has been very, very much misused. It's the first one we were familiar with was a balun, which is just a shortening of balanced to unbalanced. An unun should notate that it not only is it a matching transformer, but it reduces common mode, just like a balun does. That's the whole purpose of the balun. It's not really for matching, although there's 4-to-1 and 1-to-1, but it really gets common mode off the outer shield of the coax. And the short and long of that is that coaxial cable has a center conductor, a dielectric, and a shield, whether it's solid shield or braided shield. And because of a quality called skin effect, on coaxial cable, the inside of the shield is one conductor, the outside of the shield is a totally different conductor at RF frequencies. So you can have transmission line currents, which is the desired current on the inside of the coax, but you can have common mode on the outside. So if we think of a center-fed dipole, say 33 feet on a side, and you don't have a effective balun on there, the outside of the shield is a separate conductor. So now we have really 3 wires on that dipole, and changing the length of the coax changes the match, it changes the tuning. So the idea of an unun is the same thing. It's unbalanced to unbalanced, but it denotes that it also has the property of reducing common mode. And so all these things are not ununs on these end-feds. They're really transformers. And whether you use the 49-to-1 or 64-to-1, it really is going to be a function of how high the antenna is off the ground in terms of wavelength, because at 80 meters, an antenna 66 feet high is considered very close to the ground, only a quarter wavelength. But at 10 meters, that would be very high in the air. So the end impedance is going to be a function of the diameter of the wire and how high it is in the air. And you might just, if you're really concerned about the match, and with these unons, they're the 27 turn secondary, 3-turn binaural primary. There's not much you can do there to change that. I would say if you're going to go to a single band, like 40 meters, as the question implied with the 66-foot wire, I would use the L network. And you can't put an unon right at the matchbox. The impedance is the common mode impedance is way too high. There is no unon that will be effective at that high impedance. What you want to do is place it back a quarter wave, or on 40 meters or 33 feet back from the matchbox. That's a current maximum, and even a mediocre unon will be effective there. But placing the unon at the matchbox is just useless, or almost useless, I would say. Even if the best balance today in unons are today that have the most common mode impedance are self-resonant ones. And that's the topic of balance in unons is probably a whole different podcast. But self-resonance, that's what we use on our 6-meter omni angle, by the way, is a self-resonant balun, inside the matchbox. And if you have that self-resonant, the common mode currents are so small, you don't even need much in the way of ferrite. That ferrite is only about 0.6 of an inch long and a little over 1/2 an inch in diameter. But because there's hardly any currents in it, there's hardly any power loss in that unon. So I see so much incorrect information on the internet, on YouTube in particular, about how to build a balun. And once they build it, the only thing they measure is the SWR. They don't measure the insertion loss, and they don't measure just how effective it is in terms of choking off the common mode currents. Both those measurements, by the way, can now be done with a $100 nano VNA, but people don't seem to do that. All they're concerned about is the SWR. And that is a function of a transformer, not a function of the balun or the unon.
Interesting. Thank you for that. And thanks for indulging me on this topic. We're going to get to some of the other stuff that you've been into very shortly here. But here's a question from Mike N2MAK. What do Tim and Dale think about trade-offs between loss from traps and coils versus radiation patterns? Example, using an 80 meter end-fed half wave would create lots of lobes on 20 meters. There's always a compromise.
Yeah, that is a tough question, because the listener is absolutely correct. It's going to be multiple wavelengths on 10 meters, and that can be good or it can be bad, because now you may have lobes that are picking up local noise that the fundamental figure 8 pattern might not. So this is a lot of years ago now. What I did on the EF 10, 20, 40 antenna was, it was a half wavelength on 20 meters, therefore a full wavelength on 10 meters. And then I didn't have a trap, I had a choke, which was a high impedance to those bands, 10 and 20. So you might think of it as a trap, but it didn't require a shunt or parallel capacitor. But it looked like a loading coil on 40 meters. And so you had this 33-foot wire, you had the choke, and then, as I recall, about a 7-foot tip. And that whole system together, the 33 feet plus the choke plus the tip, resonated on 40 meters. So on 20 meters, it still looked like a half-wave wire with the figure 8 pattern. On 10 meters, it had the cloverleaf pattern. So you can start to use these traps, and if they're well done, that's probably a good solution. They do add complexity and weight, however, and tuning probably becomes a little bit more complex.
Hey Tim, what do you have any thoughts to weigh in on?
I don't care for traps and things like that. I find them lossy. That's why we went with the capacitor insertion on the 80 meter one. But this is one reason why I just link them, right? I mean, I wouldn't want to mess with, trying to figure out all of the stuff on 20 meters using an 80 meter antenna. I would just put up the 20 meter antenna and do just as well. because weight and complexity are things when you're out in the field. It's one thing to be doing that in the shack and you've got your base antenna and you can, experiment and stuff like that. But if you're in a situation in the field where you've got limited time or limited space or limited, or limited power, just about everything, I've always found the resonant is the way to go.
Yeah,
I know Mike likes his coils. I don't care for them at all.
Yeah, there's nothing.
That's my 2 cents. Yeah.
Traps can be made quite efficient. Sure. I think I saw another person that was using links. So they had at the end of maybe a 66-foot wire, and in there at 33 feet, they had an open circuit, and you could put some wire around there to then connect it and make it longer, and maybe you do another link for another band. It's a little inconvenient if you're doing POTA or something like that, but certainly that's a way to maintain a half wavelength on every band.
Mm-hmm.
Okay, thanks, guys. I want to shift gears a little bit here. Dale, you mentioned the Omni angles. These are really cool antennas. Could you tell us, you mentioned the 6-meter one. Could you just give us a little bit of background on this series that you have, which are VHF and UHF monobanders, right?
Yes. So I recall when I was a kid, this Elmer of mine, he took me to a ham fest, and he had a I think a Lafayette 6-meter AM transceiver in his car. And on the back, he had a PAR, no relationship, but a PAR halo antenna. And it had 3 rings on it because when you take a half wave antenna and you fold it into a circle, the impedance drops radically down to around maybe 15 ohms or so. So the 3 rings really made it into a 3-wire folded dipole. We know with a 2-wire folded dipole, it converts the typical 73 ohm impedance up to 300 ohms. Well, that's what those 3 rings were for. It took the 15 ohms, 16 ohms, and converted it up to 15 or 45 ohms. 50 ohms roughly. So that was my first experience with an Omni antenna on 6 meters. So I kind of looked at these, and I modeled the halo, the typical halo or squalo antenna, using Roy Llewellyn's EasyNet program. And the first thing I noticed was it really wasn't Omni at all. It was more like an elliptical shape, and it had as much as 6 dB front to side. So it was out of Omni. And then I recalled an application note from RCA, probably back in the 1950s. And it had this weird looking antenna that was triangular shaped. The pattern was nearly a perfect Omni. Now, there's other things you could do too. We might be familiar with the FM radio turnstile antennas. They're a pretty good Omni too. But this triangular one kind of fascinated me. The odd part was, number one, it's the Omni pattern is a function of the shape of that isosceles triangle. Let's call it the side to base ratio. And as you make it too thin, it becomes less Omni. As you make it too fat of an isosceles triangle, it becomes a poor Omni. The other problem was, well, like the halo, it had a resistive, the feed point impedance was resistive, around 15 or 16 ohms, but now because it's longer than a half wave, and I don't recall how much longer, let's say 10% longer, it now also has an inductive component. And it's in the instruction manual. I don't read that any longer, but I think it's around 16 or 17 ohms resistive and about 90 ohms inductive, plus J90. So we've got this really good Omni, but you can't just directly feed it. And so I started looking in one of my synthesis programs how I would get that 15 ohms plus J90 up to 50 ohms. And I have a wonderful program that Hewlett-Packard used to make. No, I'm sorry. It started out with a ham in Georgia. and it's called Genesis. And it is a fantastic simulation synthesis program. This thing is so powerful. Now it'll show you where the heat is in a circuit. It just does absolutely everything. It probably sells for about $20,000 today. But I've got an old version, which they've got different modules for it. So you can do audio filters, you can do transmission lines, you can do microstrip, all kinds of modules that you can buy and put into this thing. And so I started looking at matching networks. And because the antenna is a balanced antenna, like a dipole, I needed a balancing network. And I came up with this circuit that uses a high voltage capacitor in shunt. And that took care of getting the 15 ohms up to 50 ohms, and then 2 high current capacitors in series. And that got rid of the J90. Each one got rid of J45. So each capacitor was minus J45. So now we've got a 50 ohm impedance. But it still, I thought, needed a choke in there. And so, as I described earlier, we've got a very small self-resonant choke, which gets any RF off the coax, which the halos and squalos do not do. So it was really just a wonderful design. And high current and high voltage capacitors are very expensive these days, very expensive. And you can't get the exact value that you want. If you need 55 picofarad, you're going to get maybe 47. 56 may be a rare one in high current, high voltage. So I came up with this idea of using a microwave circuit board. And I just ordered one. It's 18 by 12 inches. It's double-sided. And unlike G10, which is a fiberglass board, or FR4, which is a composite board, this stuff has a Teflon composite. If you try to make a high efficiency capacitor out of G10 circuit board, double-sided, it's just a parallel plate capacitor, or the composite, the efficiency is very low on it. And if you try to put power through it, it just catches on fire. Don't ask me how I found out. But, so you can order this stuff, and it's $300 now for a 12 by 18 sheet. And what I do is, it's 17, no, I'm sorry. I got to think on this. 23 picofarad for what I use is 23 picofarad per square inch. And so what I do is I use a circuit board shear, and if I need 45 puff, I just do the math of the area of a rectangle at 23 picofarad per square inch and shear off what I want. And I get it well within 1%.
Oh, geez.
It is very high voltage, probably 4,000 or 5,000 volts, and very high current. You can pass amperes through that. So instead of having to live with off-the-shelf high voltage, high current capacitors, I shear this circuit board to what I need. And I guess I'm revealing some secrets here. And so there's 3 capacitors in there. And the only thing that makes the omni angle relatively low powered, about 200 watts, is my balun. But I really want this thing to perform as a good omnidirectional antenna. So all my omni angles have very high efficiency chokes.
Are these suitable for mounting on a tower leg, or should they be on a mast up and in the clear?
In the mast in the clear is ideal, but if you think about it, most of us are using Rowan 25G towers, some 45G. The side of that tower, the horizontal portion, is pretty small. Maybe 11 inches for Rowan 25. This antenna is horizontally polarized, and a tower is vertically polarized. And the side of it with the 5/16 bar, galvanized bar, is 11 inches. That's way, way too small to be seen by that antenna. In other words, it will not conduct any current whatsoever. If the side of the tower were 108 inches, it would be a huge problem and would act as a reflector. But there's no pattern distortion. I've modeled this also in EasyNet Pro. There's no, it may change the tuning slightly, but it does not affect the pattern. It might at 432, but there it's pretty easy to put a sidearm on there. I'd have to think about it for 432. That's a good question. The answer is at 6 and 2 meters, the tower is invisible.
Beautiful.
The
I may be ordering. I may be ordering one off you. I've had my eye on one for a long time. All right.
One of my friends, my EME buddies out in Colorado, who is now a Silent Key, he stacked 4 of these 6 meters on his tower. And the stacking distance is ideal stacking distance around 15 feet. So you've really got 3 gaps there, 45 feet. So it takes some room, but he had a 120-foot tower. And he also had a big Yagi, and was a real contester. And so he was always missing contacts, ground wave contacts, because the Yagi is such a narrow forward lobe on it. Whereas the Omni angle, you might say it's always pointed in the right direction. And net controls. I talked to a group over in Knoxville on 6 meters, and they're all using Omni angles over there. And it's extremely important for the net control, because he doesn't have to call CQ north, northeast, and go around the compass rose. He's got equal gain in all directions.
I think somebody needs to go outside.
I think you're right. I didn't know if she wanted to come inside or outside.
No, she's looking to go out.
Yeah.
So, Mike, N2MAK alluded to this earlier, but those Omni angles have a tremendous reputation amongst VHF, UHF aficionados. They are really something. Dale, I don't know if you want to take a moment to chat about these at all. I know that you don't. I think you might still make the 10-meter HF rectangle. Are you still making it, or is that no longer?
Yes. Yeah, I did. We had 20 through 10, including work bands, and they were hard to make. All of them were less than 50 ohms, and on those I used what's called a beta match. I think it was High Gain popularized the beta match on their antennas, but many times they weren't lumped inductors. They were strips of aluminum going back, and so what it does is it just another way to raise the impedance. And they were hard to build on for all the other bands, but on 28 megahertz we still build those. It's a pretty darn popular antenna. It's not quite as good an Omni. It's probably 3 or 4 dB out of Omni, if that is your intent on 10 meters. But I've heard a number of guys using them as a beacon antenna, more so the Omni angles for beacons. But it's a broadband antenna for its size, and you also, unlike a vertical antenna, you get ground gain because it is horizontal, and the ground gain is simply the reflection of your antenna in the ground. So you're getting the direct ray and the reflection, the ground ray, and so it does have gain over like a quarter wave vertical, even though it's pretty darn small.
Would you say it would be suitable for a portable application, or does it take some setup, and you wouldn't necessarily want to have to put it together quickly in a portable setting?
It's pretty darn easy. We on the Omni angles and on the HF rectangle, I use anywhere there's an RF connection, we use aluminum hardware. And you might think, well, aluminum, that's pretty soft stuff. But even they put a little magnesium in it, I think, for the lock washers. But you get no galvanic corrosion if I'd use stainless steel. And everything else on the antennas is stainless steel. The connectors are all Teflon. There's none of this Delrin insulation. Everything is high end on the antennas. And it just happens that the screws we use on the Omni angle, the 6 meter, and on the HF10, it's a quarter 20 aluminum screw, and we put Noah locks on the threads inside the aluminum tube. So it also guarantees no long-term corrosion, but it also guarantees that 5 years down the road, that screw is not locked into there. It's a grease and a corrosion inhibitor, so you can always disassemble these things. The reason I mentioned the screw is It's a round head or button head screw with a slot. It's not Phillips. And so you can take a dime or a penny out of your pocket and unscrew and screw those things together. So
I love that.
Yeah, it's really, you do need a 7/16 wrench, an end wrench, for the mounting bracket on it. But everything else is pretty darn simple to assemble. And a lot of the guys are using these POTA and soda just because they are easy and lightweight to put together. And the same thing with the 6-meter Moxon antenna, extremely lightweight, and easily assembles and breaks down for hiking.
Fantastic. Okay. Shifting gears a little bit again. You're into filters. You've been into filters for years. You sell them, like you're still selling them, I presume?
That's our main business, is filters.
Okay. And you sell them not just into the amateur market, but into military and commercial markets as well? Absolutely.
Yes. We've built filters for NASA. That's an interesting story, a little long, but and the FCC.
Please. You know what? If you don't mind, I'd love to hear it.
Okay, so the NASA problem was we were doing business with a company called Vizsla out west, I think in Colorado. And one of the employees from Vizsla stopped by my booth at Dayton one year. And he said, we do a lot of installations at municipal airports. And we have a Unicom frequency. And I'm not a genius on this, but I think that's where the tower talks to the airplanes, probably when they're on the ground. And we also have, what they do is they install AWAS. It's an automatic weather reporting system. And I think what the pilot does is he goes to a certain frequency and he clicks his mic 1 or 2 times. And this AWAS comes up and gives them the weather. Well, it turns out that AWAS transmitters interfere with Unicom, and Unicom interferes with AWAS. And there's always different frequencies. The FCC assigns a number of different frequencies to them. But they didn't have a solution for this except perhaps physically locating the antennas a long ways apart. And most times that really is not a possibility. So what I designed for them was it's a variation on the first filter I did for 2-meter hams that were just getting slammed by the pagers. 144 to 148 ham, and the pagers have a spectrum at 152 and 158. And you can construct the third order intermod equation and see why these pagers just nail the 2-meter market. So anyway, that is an asymmetrical filter. It was my first filter patent. And so if you think of they're notch filters, if you just roughly think of a notch, it's like the letter V with horizontal wings on either side. So it passes frequencies below the V and above the V, but notches out the V. The unique thing about my patent was that I could make this filter very asymmetrical. So it might recover extremely quickly either below the notch or above the notch. And this is exactly what these mini airports needed. So I would build a filter for the AWAS transmitter that passed AWAS, but had a very deep notch on Unicom, and just the exact opposite asymmetry for the Unicom. And my gosh, it solved so many problems, and we still sell piles of those today. Each filter is unique. The client gets a vector network analyzer plot. We have a beautiful Siglent VNA. So they get a plot of both those filters. They can see what the loss is in the passband, what the notch loss is, and it also has a custom label that has the part number that indicates the pass frequency and the notch frequency. And we just we make piles of those today. And for the FCC, the first ones we built, well, these weren't for the FCC, but the FCC contacted me, and they said, "Look, we're getting all these complaints from commercial shipping on the Mississippi River, and all these boats are complaining they're hearing pagers." And someone, one of the FCC employees. Of course, they used to all be hams, but now that's a bit of a rarity. Anyway, he said, "Look, I've got this filter that Par makes, and let's try it," because it had the same notches on the pager frequencies, and it immediately solved that problem. However, they couldn't transmit through it because the marine band was up above the 152. So I had to change that filter to make it asymmetrical to recover very quickly on the high side of the notch. And so that was kind of interesting. And for years, that was my main business. I guess we kind of filled up all the traffic on the Mississippi. And then, of course, pagers are kind of a rarity today. But today we make tunable filters for the FCC. They might be doing site evaluations, and their spectrum analyzers. Many times there's a lot of co-located transmitters. And so maybe they want to look at the FM band, but they've got something in the, I don't know, not pager band, but two-way radio that might be overloading their spectrum analyzers. And so we make these tunable notches so they can place a notch on the interfering transmitter. It could be a TV transmitter also. And then that brings their spectrum analyzer back into linear operation. So that was kind of interesting. We built them there was a company that called me, and he was a bit like me. He was kind of a solo entrepreneur. And people say, "Why don't you expand Par?" And I say, "Because I don't play well with others." This guy was exactly the same way. He was up in New England doing work for the military, and they had a vehicle they were using over in, I think it was Afghanistan. It was used to locate and explore unexploded ordnances. And so they had all kinds of GPS going on in this vehicle for location, temperature, all kinds of things. And then they had a video camera that would also be looking at where the ordnance might be. Well, it turned out that I'm not sure which was which, but either when the video camera came on or the GPS was sending out a burst, it blanked out the other. And so I built first of all, I used my Genesis program to synthesize and simulate the filter for their needs, and then built it. So a day after their request, I had shipped them a filter for evaluation, thanks to mostly to Genesis. And I had to ship it overnight air to the Middle East. It turned out that was wasted money, and it cost a ton because it was Ramadan over there, and everything was shut down for Ramadan. So it didn't get tested for a week or so, but it was a raving success, and they ordered a whole pile of those. So you might think this filter market is kind of limited. I get, there was a company that had, they were using meteor burst over in Asia Minor, and they were measuring snowpack data. But their receiver and their transmitter were interfering with one another. And so I built just a pile of filters for them. We've got filters in outer space on small CubeSats for the same. These are bandpass filters mostly. Filters that are under the ocean. They're measuring ocean currents, and at predetermined locations, they apparently blow up a balloon, which causes the device to come to the surface, and they can then transmit their data. I think it's UV from the sun eventually explodes that balloon, and it sinks back down again. So the applications that I've seen are just endless. Sometimes I don't know what they're doing with these filters, and they don't tell me. That's just fun. They just tell me. Yes, it's better because I won't have a guy in pinstripe suit showing up at my front door.
That's right.
But it's been just fascinating, absolutely fascinating. I love the work, and the antennas are fun, but the filters are really, it's always something different. And many times I can't realize the filter. Sometimes they want to have a pass and notch that are 100 kilohertz apart. You can't do that in the real world. And sometimes even closer. So I apprise them of that. And there's a filter company in Florida that makes crystal filters. And they'll make them for any frequency you want. If it's a one-off, it's probably a couple $1,000s. But if you need a bunch of, maybe that's a solution for very, very narrow filters. But that's been my bread and butter, and I still just love building filters to see if I can solve that problem.
Nice. Chris, as a retired broadcast engineer, do you have any filter thoughts, stories, etc.?
No, we didn't. No, we were dealing with in the analog NTSC days. We were dealing with like having to put in like delay lines and stuff like that to brute force time, synchronized video signals. But as you're talking about filters, though, I remember when I did my double E years ago, I took a course in digital filter design, and it was a fascinating class to take. And I remember like our final assignment was he gave us three signals, and we had to filter out the first and the last and pass the middle one, right? So you had to do all the, and of course you know all the, I don't remember it now, but you had to like pick a model, Chevy or Butterworth, whatever it was, and you had to do all the work there. Then you had to run it through whatever software we were using. And back then it was like really rudimental kind of software. And I had a dot matrix printer, and I print the thing out, and it came out. It worked. I said, "Oh, this is great." So I turned it in, and the day we turned in our final projects, we were taking the final exam. So while I'm taking the exam, the professor comes over and he has my printout with him, and he says, "Are you sure you want to submit this?" And I was like, "What? Why?" I'm taking the final, and he asked me this question. I was like, "Why?" He says, "Are you sure?" And I said, "Well, why?" And he showed me another guy's printout, and here was a different. And Dale, you're going to know exactly what I'm talking about. I tell you. His printout had a flat line, and then the signal showed up. Mine was the signal, and then a flat line. So I looked at it, I said, "Oh," he says, "there should be a delay going through that filter." And I said, "Oh," and he says, "Do you know what you did wrong?" And I said, "Yes, I entered the data into the thing backwards." He goes, "Okay, you know what you did wrong. We're fine." And he walked away. Yeah. But so
especially for filters. Phase delay or group delay is extremely important, or else you corrupt the signal. And
correct.
Yeah, very important.
Yeah. I mean, but this was just a matter of me. Like I just put it into put the data in wrong. But I did I had to do all the calculations by hand and type this, all that information. Man, it was nuts.
What I know about digital filters would go into a thimble, but I do read about them. And I was going to tell you too that the thing I did for NASA, which was kind of interesting, and that was through the same company, Vicilla, because they were doing stuff for NASA. And one of the last things they do before they press the big red button is they look at thunderstorm activity in the area. And it turns out the spectrum they use, part of it involved the FM broadcast band. Now, they knew where the local stations that they would hear on ground wave, and somehow they either ignored those or had gotten rid of them. What they didn't account for was sporadic E-skip, and it would give them false positives. So I designed a very sharp filter that would pass just their spectrum. And I just don't recall enough about that filter, except that I had to give them serial numbers on it. And I thought it was quite a unique filter, and had to give a statement for each one. It was very interesting work, but it did solve that problem.
Okay, good stuff. Hey, let's change gears a little bit here. Dale, something you love to do is restore old gear.
You bet.
Oh man, you want to talk us through some, like, how did that get started, and where do your strengths lie? What are your targets? Just look at these. These belong in a museum.
That I grew up in that era of vacuum tubes, and I always remember going to Hamfest. Well, even today, if you go to Dayton, you can be 100 feet away from a Helicrafter's receiver, and you can tell it's a Helicrafter's, or a Clegg, or a Gonset, Hammerland, all that. And today, I could be 10 feet away and not know if it was a Yaesu or an ICOM.
That's right.
And so having grown up in that era, I just so appreciated it. And one of my concerns was that this would be lost to history. These radios were many times rusty and broken dials on them. and they would just be thrown into the dumpster. And so there were always certain radios I wanted as a kid, but I couldn't afford. And so when I would see one of these, and some of them are common, like the Heathkit twins here, others are very, very extremely rare radios. And the list there it represents about 80% of them. I really need to, I don't do my own website work. It's more of that magic to me. So I've got a really talented guy that does that website work. But and I think I've really pioneered some of the restoration techniques that I use. Sometimes it means generating an entirely new front panel. The front panel is so far gone or has holes in it, and especially radios like Johnson, E.F. Johnson, they never use primer on any of their front panels. So they rust, they chip, they get what I call mole lines underneath the panels. And indeed, when you strip them down, you'll see a little mole line of rust, and that's what's causing the paint to bulge out. So I restore these radios and try to make them like new. Any hardware I put on is always stainless steel, and sometimes I have to reprint a label from the back panel or put it in Photoshop and sort of restore it. There are just so many things to restoring these radios, and I keep them for varying times after I restore them, maybe up to a year or so. I think my longest one now is my Gonset G76, the only AM transceiver, HF transceiver ever built. But eventually I find good homes for them. And so I'm not a hoarder. Currently I have my G76. I have WRL Galaxy. I'm sure you remember Leo Meyerson and that line. He made a lot of sideband transceivers, and one of his last was the GT550, 80 through 10 meter sideband CW using sweep tubes, and each new one he came out with would run higher and higher power, just like the Swans. But the rare version of that GT550, High Gain eventually bought out that line, and they made the GT550A, and it has the classic High Gain colors on it, the High Gain symbol on it, and that's what I have now with the external VFO, and I use that a lot on single sideband. But I don't keep these radios. All of them eventually find good homes. And the Clegg, I didn't tell you this, or maybe I started to. I think I did. The Clegg 22er that is now the Clegg 1010er. And I'll be on the air and people say, I never knew Clegg made a 10-meter version of that radio.
They didn't.
Yeah. Other companies did. Lafayette made 10-meter versions or 6-meter ones. And Gonset did that with their G28, a knockoff of the G50, that sort of thing. Anyway, it's a Clegg 1010er now, and I love the sound of that thing. And I built a very clever, I think, VXO for the bottom. So tunable receive, but like most of those radios back then, you could plug 1 or 2 crystals in at a time. And on the Clegg, it was just 1. So I bought these little HC49 crystals. The Clegg uses 40-meter crystals, 7 megahertz crystals. And I got one every 10 kilohertz and did a little build with a rotary switch on it. And then I used a series inductor capacitor so I could warp each crystal. 2 or 3 kilohertz on 40, by the time you get up to 10 meters, it's 4 times wider. So I can go directly from 29 even to 2910, 20, 30, 40, and then plus and minus 6 or 7, 10 kilohertz. So that allows me to zero beat anybody on 10 meter AM. I just love that little radio. And it took a long time. It didn't take that long it took me a year to get started on it. But when I finally got started, it really worked pretty darn well. But at night, I would hear AM stations. I thought, what is going on here? And they were shortwave AM, and they were coming in just above the 40-meter band. That's a huge hotbed of shortwave stations. And I looked at the VFO, the way I had redesigned the VFO and the first IF, and the higher image frequency was falling at around 7 to 7.5 megahertz. So I made a trap for the input, a series trap, a series LC network to knock out the short wave. That solved that problem, but I could never get that transmitter to be stable. And I grew up in the vacuum tube era, but I had never had to design my own neutralizing network. I knew that these transmitters all had them, but I didn't know how to do it. And I finally asked a 10-meter friend of mine out in Arizona, K0ETD. He had built his own, and he sent me a schematic of his neutralizing network. And so I rebuilt the input and output stage of the 2E26 final. It worked right off. You cannot get that thing to be unstable now. But I had to find someone else to do that work for me. I just copied it. Let my in. I'll be right back.
So Tracy, that receiver, that picture you have there, when I was in high school, we built a ham shack at our high school in the electronics lab. And that receiver, somebody had given that to the school. We had that exact same radio.
Isn't it beautiful?
It's a beautiful radio, yeah.
Yes, gorgeous. Dale, I'm looking at that, and I'm imagining, before the restoration, what that radio might have looked like. And I've walked up and down the aisles at Dayton. I've seen the condition of most of these things, even the good ones. Yeah. To me, I don't know how you were able to get it to look. That looks brand new.
Well, if you're going to restore something, if you really want to save yourself a lot of time, the first thing to do is find one that has a nice front panel on it, the paint and the graphics, because doing that is really complex. So I found this radio, and the aluminum knobs were black, and that rectangular escutcheon around the dial and the S meter was pretty well scratched up. So between being corroded and oxidized and all that, and so what I do, I take each knob and I put it on my lathe, and I start out with something rough, like maybe automobile rubbing compound, and I keep getting finer and finer and finer until I end up with Novus plastic polish. And it really makes these things bright. And then if I have to, I restripe the knobs, if they've got a stripe on them to tell you which function is being brought up. And the escutcheon, I thought, I don't know how that thing is affixed. And it really wasn't clear. That thing snaps in with that is all one die cast piece. And I didn't believe it at first, but I had the whole front panel apart anyway, and I was able to squeeze that thing and pop that aluminum escutcheon out there, and then polish that thing out also. And that may be what's called a rubbed finish, where if you look really at it closely, it has really fine parallel lines. They're really fine. And I developed a technique to do that also. I don't know if my cat's going to show up in this or not. We have a feral cat.
Hey, it's Halloween time.
No longer feral, but I'm going to have to bear with me just a second, because he's an enormous cat, and he will keep. Here he is. Does that show up in the camera? That's Boxy.
Oh, yeah.
Holy cow.
He's a long hair, and he's no longer feral, but he likes to come in.
Clearly, he's letting you pick him up.
Yeah, that is feline physical fitness to pick him up.
Yeah, right.
One of the other things I discovered, and when you look at these chassis on all these rigs, because they're vacuum tubes, they have grill openings in the top, and that allows nicotine or whatever is in the home to slowly settle through there. So if the chassis are aluminum, they survive a little better, but if they're steel, they're all just really etched. And I just kept thinking, of course, you could on a DX, HR10B receiver, Heathkit receiver. I took everything off the top of the panel, even the IF cans, and a few things I couldn't take off were masked over. But I sanded that down, and I painted it with not aluminum paint, but it's a flat nickel, which really looks more like aluminum than the aluminum paint does, and that came out extremely well. I don't think that's on the site, but on my Godset G76, I just didn't know what to do with the power supply. It had a lot of just a mess on it. So I kind of sanded down all those rust points, which are raised up or oxidized points. And I found this material. It's called Rough and Buff, RUFF ampersand BUFF. And you can get it in different colors. And normally people use it on shoes to restore leather shoes, that sort of thing. But I ordered some in the aluminum color. This stuff is absolutely amazing. You wipe it on, and it covers up all those discolorations. The steel looks absolutely like new, and I published that in Electric Radio, one of my best hints ever, I think. And I've used it on a lot of chassis. You can also get it in the brass and bronze. For instance, the Clegg 1010er has not anodized, iridized finish, which is what they do to steel. And it's kind of a faded copper or brass color. And that rub and buff just made it look absolutely like new. And it dries, very, very thin coat, but it dries. So if something still shows through, you can do it a second time. And it just works miracles on these old chassis.
Hey, here's a question about the Morrow transmitter.
Oh, yeah.
Would it do around 30 watts? Does that sound about right?
Yeah, 6146 horizontal. Yeah, they're beautiful.
I may be the only guy in the room thinking this, but I'm going to give you my thoughts on it anyway. If somebody were making a radio like this today, I'd want one.
Yes.
Forget the waterfalls, forget all. If somebody, this is a beautiful piece of technology. Now, I'm not talking necessarily with vacuum tubes, but if somebody came out with something that looked like that and wasn't cheap plastic, oh my gosh, I think they might do well with that.
Yeah, it's they were, as I say on my website, they were the Cadillac of mobile radios back then, the Morrow twins. The earlier one had a slide rule dial. I don't recall the model numbers any longer, but this is a drum dial. And the problem, you can't find these anywhere. When I did find them, the graphics were gone. That panel is stamped, and at one stamping, they curve the edges, as you can see, and all the lettering and numbers are also stamped, and they are extremely shallow stampings. As I recall, those knobs are also aluminum, I'm quite sure. It's been a long, long time. But anyway, I sent this out to a friend of mine who restores R390s, and he is type A, does not begin to describe Glenn. He's off the charts. Harvard's going to want to see his brain someday. And because he does this preparation on the lettering on the R390s, I sent it to him, and he fooled with it. And he said, they're just too shallow. I can't do it. So he returned them to me. And I think I didn't sandblast those because it was aluminum. I think I sanded them down, took an X-Acto knife and got out any remaining paint. And what I started using was gloss latex. So if I did screw it up, it wasn't like using oil base where you've got a mess on your hands. And it would take the primer off. I used aircraft aluminum primer on that. And so I didn't have to reprime it each time. And I would take almost a zero nap cloth, and I would put the paint, just kind of put it in there with a Q-tip or a paintbrush, very fine paintbrush. And then with water on the cloth, I would just wipe it very, very lightly. And darned if I wasn't able to replicate that lettering just perfectly. It was painstaking, but I did it. And the other thing with the Morrows, that cabinet is kind of thin and flimsy, and they use sheet metal screws on that. And what I do on all those radios that use sheet metal screws, the chassis are steel, and what I will do is clean up inside the hole, and I will take a brass hex nut, and I've got them in 440, 632, 832, and 1032, and I will use a stainless steel screw to put the nut up against the inside of the chassis and put some flux on it, and then solder that nut on there. So now I can use machine screws on it instead of these cheap sheet metal screws that'll constantly strip out. And so everything is stainless steel on there, and just really, really nice radios. I found somebody that really, really had to have that set, so I no longer have it. But
I bet.
It was a big job but beautifully built. If you've ever looked inside a Tektronix oscilloscope where they use those terminal strips with like phenolic and the little terminals on them, upright terminals, that's how everything in there is wired.
Wow.
And electrically, it really did not need that much restoration. It was mostly getting the thing to look like it hadn't been run over.
Jeez. Hey, Tim,
it really is like an art form, the way they designed those radios back in the day.
It is. Yeah. The form factor is what really gets me. The low height and the wide radio.
Yeah.
That's a beautiful form factor.
Yeah. Yeah.
Hey, Dale, I don't know if you know this. Philip is asking a question. Was the Eldeco line basically a Collins knockoff?
Yeah, it sure was. They were licensed by Collins to make the S line. Have I got that right? Yeah, the S line for war during World War II. S line? I've got to picture this now. Anyway, they were licensed by Collins to make these, but only for the war or a war. And Eldeco decided that after the war, they would so it's probably the 75 line, KWM2 line, that sort of thing. And so I had 1 kilohertz calibration and all that. The pre-selector in the upper left is a little weird. It uses that window is I think I'm correct, an oblate triangle. I didn't find that nearly as attractive as what Collins had. But anyway, they kept making this stuff after the war. And Collins didn't let that go on for very long and sued them. And they had to stop. So absolutely, I think they're pretty much all Collins stuff inside. They just look differently.
Hey, Tim, thoughts on this stuff?
I love it. But the tooling and the equipment to do it anymore is long gone. So is the knowledge on how to operate it. To recreate something like that, it would be you're looking, $10,000 a radio. So as much as we would love to see it again, you might get some plastic version of an injection molding for the case or something like that, but certainly not the metal. And you would you would have the digital stuff inside. It would only look antique on its face, which is still cool. I mean, but you just, I think the lesson here is to take care and maintain the stuff that's out there now. And if you can find one that's in decent shape to carry on the tradition, as it were.
Yeah.
I had a very interesting email from a woman out in Las Vegas. She's now in Florida, but she was the founder of Eldeco. I don't recall his name now. It wasn't Eldeco, but she was his daughter. And she knew of a number of different businesses that he had. She never knew anything about Eldeco. And she wanted to know where she could get a sample of an Eldeco piece of equipment. And I forget what it was. It may have been an antenna tuner that I found for her. But I thought, that's really crazy. This guy's running a pretty good sized business. And the family doesn't know what he's doing when he leaves the house on Monday morning.
That's not that unusual.
Sorry?
It's not that unusual. It's not unusual at all.
Yeah.
Okay, it's time. We got to shift gears a little bit here. We got one more topic I want to get into here, Dale. Something that you're keen on.
Oh,
EME, Earth, Moon, Earth. Tell us a little bit about moon bounce.
Well, it is still.
And by the way, sorry, most of the people on here are probably not familiar. We might have the basic concept, but if you want to give us a little bit of a deeper dive on it, that'd be good.
Yeah, if you go to my website, there is a story up there, and I was always fascinated by it. I had but I'd never done anything about it. And a friend I met when I lived in Florida, K9BCT, he was an engineer with Motorola. He had built some long Yagis for 2 meters, but had then stepped up to 432. So he sold our local radio club. Kind of thought maybe they'd like to try to do moonbound. So it was a club project. And Randy sold us his 4 Yagis, and we made maybe even the H frame to stack it on. And that was for 2 meters. And somebody else had a solid state amplifier, about 250 watts or so. And we set it up in one of the club members' backyard. And the ARRL VHF EME contest was coming up. And I was not responsible for stocking the Yagis. That was done by another ham. And so we got on Friday night when we had moonrise, and we didn't hear anything, just nothing. And I started looking at those Yagis, and I saw these things are mounted wrong.
They're backwards, right?
Yep. Instead of having a forward low, we had a forward null. And the fellow that had stacked them said, no, that's the way to do it. And I said, well, we didn't hear anything tonight. Let's do it my way tomorrow night. The next night, it sounded like 20 meter CW. And it was really fun. But I talked to my friend Randy, and he was then giving up on 432 and was going to 1296. I said, why 1296? He said, number one, you don't have to use a pile of Yagis. You can use a dish antenna. And with the advent of the C-band TVRO home satellite system, parabolic dishes were getting fairly common. Mm-hmm. And so I looked at this, and one of the other features is that at that time, and still some today, as a linearly polarized signal goes through the ionosphere, it gets rotated. And so you may be trying to reach an Italian station. Your Yagis are horizontal, his Yagis are horizontal. But because of what's called Faraday rotation, you may be locked out for hours at a time. The signal shifts 90 degrees or plus or minus 90, and you just get locked out. I thought that's no way to operate. I want to hear the strongest signals possible. Well, on 1296, pretty much from the get-go, they had developed circular polarity. So if you go circular, and so we go circular up to the moon, like a mirror, it gets reflected back counterclockwise. And initially, they were using relays and quarter wavelengths of line to change from circular to clockwise to circular counterclockwise. And the problem with that is there's loss in those relays, there's loss in those phasing cables. And so a brilliant ham up in the northwestern Canada came up with what's called a scalar feed horn, and that's the one you see here. It's a little, it involves vectors, and it's a little complicated, but it has 2 probes on it. It has a transmit probe and a receive probe, and there's no relays, no phasing cables, nothing. And the way we illuminate the dish, if you look at that cake pan, I've got to let a dog in. Excuse me. I don't know if you or not, but she wants to be in. Come on, honey. Come on. So by moving that cake pan, think of this as a flashlight where you can change the included angle of the beam. What we want to do in a dish is we want to uniformly, as much as possible, illuminate the whole dish. You want to take advantage of all that metal that's up there. But you know how you can take a flashlight, especially modern ones, and you can change that included angle from something narrow to something wide. And by moving that scalar ring back and forth, you can change that illumination angle. So all of a sudden, we're getting efficiencies, what used to run at 55%, getting efficiencies today up around 75%. So for the same size dish, you're getting a lot more gain out of that antenna. Now, you don't want to over illuminate it, because what that dish is seeing is cold sky. Cold sky is very low noise. If you over illuminate the dish and now you're receiving off the edge of it, you're getting warm earth. And that's going to ruin your signal to noise ratio. And indeed, when I point my dish down to the horizon, it hits pine trees down below me. And I can see my noise level on the pan adapter rise up as it sees these warm trees. So it just turns out, because of dishes and now low noise amplifiers, back in the day, if you had a 2 or 3 dB 2-meter converter, that was low noise back in the day. And now with these gas FETs, you can get noise figures at 1296 below 0.2 of a decibel.
Wow.
It's just fabulous. So you combine the ready availability of dishes, and now these wonderful scalar feeds, and a new design is a septum feed, which is what is on my dish right now. Totally different theory, but they also work very well. And an Oklahoma City ham, K5JL, came up with this deal. So just because you don't have phasing cables now, you're still going to have a relay to change your feed horn. You don't want your receive probe to be hearing transmit noise. So you've got 1500 watts, if you're lucky, going up that round waveguide, and here's a receive probe sitting there. And if it's connected directly to the low noise amplifier, it'll just cook it. So Jay came up with this idea, and if you scroll down a little bit more, Tracy, so that is what you see in that picture is the original picture there. If you go back, that is the receive antenna right there. So
geez, really?
Yeah, that's a quarter wave antenna on 1296. So there's threads on the bottom of that. It's hard to see, but that probe and the whole NA box screws right into the waveguide. Now, if you go to the next picture, what you'll see is inside that, and the that off gold box is the LNA, and to the left there you'll see an SMA relay. The output of the LNA has a male SMA on it, so it screws right into the center of that SMA relay. On that's the LNA. On one side is a tiny little SMA 50 ohm load. So what happens when we go to transmit, we use what's called a sequencer. So what it first does is it throws this relay over. So now the receive probe is terminated into 50 ohms. So it's not seeing that 1500 watts coming out of the transmit probe. And then about 20 milliseconds later, it enables the power amplifier. You don't want to be hot switching these power amplifiers. And then 20 milliseconds after that, it enables the PTT line on the transceiver. And when you go back to receive, just the opposite sequence occurs. And we used to have a saying that there are those that use sequencers, and those that don't will be replacing their LNA. And that was a pretty common occurrence. So we have no jumpers, anything. It's all male to female SMAs. And I've put these SMA relays on my vector network analyzer. I can resolve 1/100th of a dB. On the N relays, I see loss. I cannot see any loss on these SMA relays. So we are hearing absolutely everything. And any loss mathematically adds up to be loss there, or loss in the feed line is equivalent to increasing the system noise figure. So by having the LNA right there at the waveguide and the receive probe, it makes up for any feed line loss also. So I can use LMR 400 going out to the shack. Maybe I've got 8, 9, 10 dB loss, but the LNA totally hides that loss. So I spent a lot of time optimizing my system as far as getting that scalar ring just right and the focal point just right. And I hear I've now got a 15-foot dish. My 15-foot dish, I'll give the same signal reports to guys that are using 18 and 20-foot dishes. So I'm really making maximum use of the value that I have out there. It's just the most. Anybody that looking at that page, if you go way up to the top, you'll see some sound files, wave files of signals and what I hear or how they hear me. And that's only when I had a 12-foot dish and about 600 watts. So now I've got typically about 1,000 watts out there, solid state. We used to use water-cooled tubes, and so now it's all solid state. And I can rag chew off the moon, or even work sideband off the moon. And it's just, at one time, we used to have a group on 3647 on 80 meters. It was summer. It was so noisy. And all of us were 1296 EMEers, K1RQG, K5JL. There's a few there. There's a W2 I'm forgetting. But we all had moon. We went up and rag chewed off the moon. No static, nothing. Just track the moon and talk. A lot of fun.
Oh, that's awesome. Well, thank you for sharing. That is an unexplored frontier for many of us.
Well, I don't know. Didn't they just have the contest here in the last week or so? Wasn't it?
Yeah, I missed the first weekend. Unfortunately, we had company, but I'll be up for it's a 2-weekend contest, and so my small station. There's guys in Europe with 40, 50-foot dishes, but my 15.
Whoa.
Yeah, my 15. They set the dishes with a helicopter under the mount.
My 15, of course they did.
My 15-foot dish,
and a lot of people
placed 4th worldwide on the CW. You know, today there's a lot of I should mention there's a lot of digital stuff, and my desire throughout my life on VHF, UHF was to see how weak a signal I could copy. And the guys on digital, God bless them, they don't hear anything. The computer does the decoding, and I just have no interest in that. But sadly, a lot of the CW guys have gone up to digital just to make more contacts.
Whoa, hang on a second here. There's the, or your friend in Europe may have 50-foot dishes, but for the rest of us humans, we don't have 1,000 watts and those things. So, JT65, I think, was originally developed for EME, wasn't it?
That's right. Yeah.
Yeah, and which became FT8 now. I mean, it was originally a moon bounce method. So what would you do? So what's a poor ham to do, right? With my 100-watt Yaesu and my moon bounce Yagi, what am I gonna, how else am I gonna do it?
I totally see it. I just think some of the magic is gone, and there's a very interesting page up on Sierra Mike 2 Charlie Echo Whiskey about the deep search decoding method of whatever they're using, JT65, and it shows how flawed it is. And my example is one of the guys I mentioned earlier, Joe, K1RQG, built a 28-foot dish, and he works 432, 1296. But he has got numerous QSL cards from hams on 2 meters claiming they worked him, because in that deep search mode, it has a call sign list. And that deep search mode looked up and said, you just worked K1RQG, when Joe has never been on 2 meter EME in his entire life.
Jeez.
I get some of this. I get some of this in my email inbox too. I get somebody sent you a QSL. I was like, wait a minute, where? Who is this? I don't even recognize the call signs or anything. It happens a lot.
Can you excuse me for just 1 minute? I need to set a timer.
Of course.
I'll be right back.
Not a problem. Well, that's it. You think there's any moon bounce in your future, Chris?
Oh, geez. Yeah, I doubt it.
It's a cool concept.
It is.
No.
Really cool.
There's no. Listen. Okay. There's going out and doing a moon bounce and successfully executing it, and then there's rag chewing off the moon. Okay. I'm happy.
Right.
I'm happy with going out with it, with the setup, and what I got, and what I can make, and do here nothing fanatical, and getting and receiving a moon bounce back. That's fine for me. That
just to do an echo, like send something up and hear it come back and be like, wow, it worked.
Yeah.
Yeah.
I don't need to.
Well, I mean, you know what? We better get this moon bounce stuff, just make it routine, because once Elon gets his boys up on Mars, then it's going to be Mars bounce, isn't it?
You're right. He's right. The magic is gone.
It's true. I think that I think looking at those radios that's the magic, man.
So Kevin, wait, go back. Kevin says rag chewing off the moon sounds awesome. It does sound awesome. All I'm saying is that it's impractical for your average ham. That's all.
Yeah, probably.
Right.
All right, guys. Well, that's fantastic. Dale, thank you so much for joining us. Do you have anything? We got a few minutes to wrap up here. Do you have anything you'd like to touch on before we sign off?
I just have a kind of a funny EME story. This was when I lived in West Palm Beach, and I had a 12-foot dish, and let's see, probably about 300 watts at the dish. And it was a Friday afternoon. I was in my shop, and I thought, well, it's we like to pick weekends when the moon is closest to the Earth, which we call perigee, and apogee is the furthest. And also when the sky behind the moon is low noise. So we're not looking at Betelgeuse or something like that, which makes noise. So it was an activity weekend, 4 or 5 in the afternoon. And so I set the dish up and fired everything up. I was using water-cooled tubes that were good for about 25 watts, and I was running them at 125 watts. If the water stops, you're in big trouble. Anyway, I'm listening, and I'm not really expecting to hear much, but all of a sudden I hear a series of dashes. Now, that's how it's called echo testing. So if you want to make sure your dish is pointed, your system is working, you go to transmit, you send 2 or 3 dashes, you go back to receive, and because it takes a electromagnetic wave 2.5 seconds to make the round trip, you hear your own echoes. And so echo test, and I think he signed his call. It was Frank in Michigan. I think it was W4OP's. I'm not sure. Frank's a silent key now. But anyway, well, he was you have Doppler off the moon, because when the moon's approaching you, your signal is increased in frequency, and when the moon is past zenith and going away, it's lowered. Just like when you hear a train come by in the tracks, as it approaches you, that noise gets louder or higher and then lower. And so when Frank was transmitting, I set my Doppler offset and 0 beated him. And the next time he goes da da da, I immediately follow with da da da. So when he listens, he hears 6 dashes. I do this for.
He's a practical joker, that guy.
Yeah, longer than I should have. And finally, I signed my call. And I get a call from Frank, and Frank was an old codger back then. And I get a call, I pick it up, and he says, Dale, I said, yeah, it's Frank. Get the hell off my moon rock.
That's a good one. That's a good one, yeah.
That's beautiful. Dale, thanks so much for joining us tonight. You've done so much. It's been so nice hearing about some of the stuff. We didn't even get to it all. You've got a whole homebrew side to you.
I know. I love talking to guys who've forgotten more than I'll ever know,
Yeah, really.
Oh, I have to read the books constantly to remind myself what I'm doing.
I find that way
very much.
That's the case with taxes with me. I have to constantly read the books.
I've got a guy for that.
That's right.
So, anything just to summarize, Dale? Anything to finish us up with before we sign off?
Well, I just ham radio is it's been a wonderful hobby, I think, for all of us. I've met so many wonderful people all around the world, obviously, and so many generous people. When I got into EME, I knew nothing, and all these guys, I didn't invent anything. They taught me what to do and how to do it, and I just can't say enough good about ham radio.
Mm. Well, you're a tremendous ambassador. You help move the ball ahead for a lot of people, and I for one am grateful for the contributions you've made. Hey, Chris, as we sign out here, any last words from yourself?
I would echo what you just said. You've it's almost like you're like this behind the scenes, like secret warrior, that's done all this work that all of us have benefited from, really. So yeah, really glad to have met and had this conversation. Fascinating, great stuff.
Tim?
Well,
I will admit that I've taken more than my fair share of inspiration from the NFED SWL. I'll just leave it at that.
Yeah.
That's neat. You know, whenever I think I'm smart, I look at the writings of guys like Roy Llewellyn. This guy is just fabulous. Or VK10D down in Australia. These guys, you know, Chris, I'm sure you've had calculus and differential equations and all that. These guys really use this stuff.
Yeah, exactly.
I'm amazed at their ingenuity and their breadth of knowledge. It just blows me away. I'm much better at looking at what somebody else has done and trying to grow from that.
So Dale, this will probably break your heart. So I've been like purging a lot of stuff, and I finished my double E in 1993. Literally last week, I threw my differential equations textbook in the trash.
And good riddance.
Yep, that and the linear algebra book, both of them got tossed out together.
Yep.
All right, guys. Well, thank you everyone for tuning in, whether it was live or after the fact. Really appreciate you having you here. Quick note, parelectronics.com is Dale's website. You'll find a link to it in the description below. Chris, Kilo 2, Charlie Juliet Bravo, just really quickly here. We're running out of time. We gotta bail, but Chris has just hit 6,000 subscribers on his channel. Kilo 2, all of you. Charlie Juliet Bravo Radio. So if you haven't subscribed, get over there and do that. Aether Wave Antennas. Our buddy Tim sells a wonderful line of HF wire antennas. Get over there if you're looking for something rugged, field worthy, going to last for years, perform well for you. That's the place to go. 7-3. We'll catch you next month. Take care, everyone. Guys, hang around for the debrief.